big welcome. A really interesting session here today. The latest in Elemental's virtual talks series. For those of you who don't know, Elemental is the online community for professionals focused on heat, water, air, and energy, which looks at how we effectively manage these elements in the built environment, both now and in the future. And today, delighted to say that we're joined by Zisis, who's a commercial segment manager at Uponor, to talk about how we can create complete energy efficiency in our homes. It's super important because obviously we have some ambitious targets as an industry to get towards net zero, but 3/4 of the construction industry believe that the sector's climate objectives are actually unachievable unless we have a major overhaul in how homes in the UK are built and refurbished. And this stat comes from a research report that we're going to find out a bit more about. So Zisis is going to share some of the findings from the construction industry research report and the white paper that Uponor published at the end of last year, and talk about a range of energy efficient solutions which both Uponor can provide, and combined with renewable energy sources like the heat pump, solar thermal, district heating, help us reach the ambitious target that the industry has been set. So without much further ado, I'll just say we'd love to hear your questions. So do post them in the Q&A box, which should be at the bottom of your screens. We'll pick up some of those at the end of the presentation. And just a big thanks to Uponor and to Zisis. Thank you so much for joining us today. Really excited to hear about some of these findings and to hear your presentation, and then we'll pick up some questions towards the end. So Zisis, thank you very much, and over to you.
Okay, so good afternoon, everyone. Thank you very much for your interest in our solution and your registration to our live webinar. My name is Zisis Nikoloudis. I work as a commercial segment manager for Uponor UK. And today I will host this virtual event where we will run through an overview of our recent white paper research report, and then showcase how Uponor solutions can assist in delivering sustainable buildings on the roadmap for net zero. The presentation will last roughly 45 to 50 minutes, and then we will use the remaining time in the end to answer your questions. So if you have any questions, please send them across through the Q&A section, and we will answer as many as possible in the last 10 to 15 minutes. Any questions that will not be answered in this call, we will collect them all, and we will answer them via an email to all attendees. So let's see what topics we're going to discuss today. First of all, we will provide an overview of Uponor, who we are, what we can offer, and how we perceive sustainability as an organization. Moving forward, we will make an introduction to the white paper research report we conducted a few months ago and highlight the key findings of our survey regarding net zero. And we will also discuss some useful facts that came out of the literature review. We will then cover the different solutions that we can offer in order to assist in delivering highly sustainable developments. And we're going to focus on 4 different pillars: district heating networks, internal plumbing distribution, radiant heating and cooling solutions, and smart controls. In the end, we will run through some project references, and we will have 10 to 15 minutes for Q&A. Okay, so let's start. Uponor at a glance. We are a leading global manufacturer of solutions for the safe transportation of water around buildings and energy efficient radiant heating and cooling solutions. We support our customers across different industries, such as residential and commercial construction, in working efficiently, delivering sustainable, healthy buildings, and developing a sustainable living environment. With over 100 years of experience in the construction industry, we are capable of providing expert advice and suitable solutions for large-scale projects and complex developments. The aim of our offering range is to provide turnkey solutions for all sorts of projects, from the energy center to the final emitter. Our offering range includes flexible pre-insulated underground pipework for small district heating schemes, multi-layer composite and PEX pipework for internal plumbing distribution, and low temperature radiant heating and cooling solutions for sustainable buildings. As an organization, we have sustainability embedded in our daily operations. Our aim is to safeguard water for future generations, and we plan to do that through innovation, engineering, and development of new products and technologies. We support all 17 United Nations Sustainable Development Goals, while our sustainable business strategy is based on 4 of them: clean water and sanitation, decent work and economic growth, responsible consumption and production, and climate action. So as we are a living organism in the world of construction, we always try to carefully listen to the challenges that the industry is facing and develop solutions that will assist construction professionals solve their problems. On that principle, we conducted a survey in 2019 in order to understand what are the challenges that the industry is facing in the design and delivery of high-rise buildings. Amongst the different outcomes from that survey was that sustainability and actually bridging the gap between wish list and reality was one of the key challenges the industry was facing. And then we thought that we need to actually take the next step, and we went ahead and undertaking a research on why is there a skepticism around sustainability when it comes to delivering high-rise developments. There were many reasons that that led us to investigate this topic actually. So let's say, despite marketing uncertainty caused by Brexit and COVID-19, there are currently over 500 tall buildings in the pipeline for London. 60 tall buildings were completed in London in 2019, and 88% of them included residential spaces, while there was also a noticeable increase in high-rise developments in Manchester, Birmingham, Liverpool, and other major cities. All these facts actually highlight that there is a nationwide trend showing changes to the way that we live and work over the coming years. In addition, planning, design, and construction of tall buildings present unique challenges in structural design, cost planning, and provision of MEP systems. In fact, new regulations are introduced in order to make tall buildings safer, and there is also an increasing pressure to reduce the impact of high-rise buildings to the environment and the surrounding communities. At the same time, those buildings need to be healthy, considering the physical and mental health of the occupants. And in addition, there is a need to reduce the energy consumption and the CO2 emissions, considering long-term operational management and life cycle costs. Therefore, it deemed necessary to understand the demands on delivering high-rise buildings and assess whether the expectation to deliver these demands are realistic in the current climate. In order to do that, we undertook a comprehensive research to gather insights on several key trends and challenges the construction sector faces on a daily basis. So we picked 200 people, including architects, consultants, contractors, and developers, and asked them their opinion on 3 key topics: healthy buildings, technology in high-rise construction, and carbon reduction and net zero buildings, with 5 questions per topic. The outcome, intriguing and compelling findings, which actually highlight some important considerations in the development of multi-use high-rise buildings. So the topic that is actually the topic of our research that is actually more relevant to our today's discussion is the net zero part. So let's see the reasons why net zero was one of the key topics of our research. First of all, what is net zero? So a net zero building is actually a building with net zero energy consumption, meaning the total amount of energy used by the building on an annual basis is equal to the amount of renewable energy created on-site or off-site. And this is the definition according to the US Department of Energy. Another definition that comes from the World Green Building Council is that a net zero carbon building is a building that is highly energy efficient and fully powered from on-site or off-site renewable energy sources. So in general, the goal is that these buildings contribute less overall greenhouse gas emissions to the atmosphere, during operations than similar or non-net zero buildings. They do sometimes consume non-renewable energy and produce greenhouse gases, but at other times reduce energy consumption and greenhouse gas emissions production elsewhere by the same amount. However, while innovative design approaches and technologies are beginning to be incorporated in high-rise construction, sustainability cannot be ensured simultaneously. Currently, the construction sector accounts for nearly 39% of all global carbon emissions, a fact that actually forced the UK government, amongst others, to introduce new regulations and strict targets. So, for example, by 2023, no new homes should be connected to the gas grid, which means that all heating, cooling, and domestic hot water systems should be provided by sustainable alternatives to today's gas-reliant status quo. Therefore, technologies that are actually likely to flourish in the near future are likely to include district heating networks and renewable energy sources such as heat pumps, solar combi, or CHP. So now let's see some of the key findings of our report. Only 4% of the respondents think the UK construction industry can meet climate objectives without major change to the approach of retrofitting existing homes and building new homes. 1/3 of the respondents believe that net zero homes will not be a reality by 2040. Only 10% of the industry think the construction sector workforce is fully equipped to deliver the sustainable houses that are needed. More than 10% of the industry think the UK will never be able to take all new homes off the gas grid, and 2/3 of the respondents feel more investment in new product development is needed from manufacturers in order to enhance water delivery efficiency, which will actually improve the building design. So based on these findings, we can understand that there are several challenges that the industry need to overcome in order to stay on track to delivering net zero buildings. Actually, a need for greater awareness and more training, comprehensive technology implementation, and more modern designs were actually recurring themes throughout the report. So moving forward, let's see some useful facts which will help the industry work towards delivering net zero. First of all, research has shown that the replacement of conventional heating sources with district heating networks or renewable energy sources can significantly improve the energy efficiency levels and reduce the greenhouse gas emissions of the development. In addition, the overall energy efficiency can improve even more by implementing alternative heating solutions which operate at lower water temperatures, or cooling systems that operate at higher water temperatures compared to conventional HVAC systems. Some prime examples of these alternative solutions are radiant heating and cooling systems, such as radiant panels and underfloor heating and cooling. So on top of all that, when smart controls are combined with the above alternative solutions, they can enhance the energy efficiency of developments even more. Discussing about water transportation, designing a water distribution system that meets the needs of the building users while reducing water and energy wastage ought to be a priority in industry's agenda. And then in general, another aspect of delivering a net zero building was actually also, we need to keep in mind that carbon footprint of a development can also be reduced by utilizing products which have lower environmental impact across their whole life cycle. The profile of products and services that facilitate the new generation of construction actually needs to be of primary focus for people involved in designing and delivering the buildings of tomorrow. One of the key topics in every sustainability discussion in the industry is district heating networks. So let's see what is the current situation with district heating networks, how they can assist in delivering systems with lower carbon emissions, and which solutions can assist towards that purpose. First of all, space heating and cooling and domestic hot water account for around 21% of the overall UK carbon emissions. 85% of UK households use gas for heating and domestic hot water. The rest 15% use either electricity, oil boilers, or another source. 65% of non-domestic buildings use gas as their primary heating source, and 40% of the overall industrial energy consumption in the UK is coming from natural gas sources. District heating covers only 2% of the overall UK heat demand, while you can see that in other countries, this percentage is much, much higher. In total, around 53,000 homes are connected to district heating networks, and less than 50% of these networks use renewable energy sources. Another interesting fact is, which actually comes out of reports from the UK ADE, is that pipework heat losses for district heating networks can reach up to 30% of the overall heat losses of the system. Looking more into detail on heat networks, district heating is actually the concept of having one or more central heat sources instead of individual boilers. The heat is transported from the central heat source through a network of underground pre-insulated pipes to each building. So each building typically uses heat interface units or some sort of central heat exchanger, which will provide space heating and hot water to the building from the district heating network to the building. District heating technology can be used with all heat sources, including conventional gas and oil boilers, CHP, heat pumps, biomass, and even recovered energy from waste. The main benefits of this concept are that the system actually produces less carbon emissions, and they lead to lower operational costs. The maintenance is easier as the plant room is external to the building, and this also leads to lower maintenance costs. Last but not least, district heating networks can work in conjunction with natural and waste heat sources. All these benefits made district heating networks one of the primary focuses on the roadmap to achieving net zero, and led to the creation of the Heat Network Development Network by BASE, which you can see in the bottom right of this slide. So therefore, we can understand that there is a direct driver for growth for district heating networks in the UK, which actually is a driver for sustainability on the road to meeting the decarbonization goals that the UK government has set. What we need to keep in mind is that one of the most important things that can play a vital role in designing and developing highly efficient district heating networks is the installation of the pipework that carries the water from the energy center to the building. Not only because this can affect the water temperature delivered to the building, but it can also highly affect the return temperature of the water to the energy center, which can have a massive impact on the performance of the energy source. Therefore, keeping that in mind, that highly efficient district heating networks call for high performance pipework, we developed our range of underground pre-insulated pipework. So the Uponor Ecoflex range includes many different types and sizes of pipework, which covers a very wide range of heating network applications. Currently in the UK, offering range, we have the Ecoflex Thermo and Thermo Pro, the ThermoTwin for heat pumps, and the recently launched Thermo VIP. So Ecoflex Thermo and Thermo Pro might look similar to the outside, but they have some big differences to the inside. The service pipe for both ranges is actually PEX pipe, but the Thermo range comes with PEX foam insulation, which achieves a very good insulation performance, and also enables the pipe to be highly flexible, which makes it ideal for the final branches before the pipe enter the building. The Thermo Pro comes with PUR foam insulation, which provides high U values, which means lower heat losses, and leads to higher energy efficiency. The Thermo Pro is actually ideal for long runs and provides good flexibility too. The Ecoflex range covers all sorts of applications for potable water and domestic hot water with the Aqua pipe. Quattro pipe combines 4 pipes in one jacket for heating, domestic hot water, and potable water. And the Supra pipe is intended for cold and potable water applications. And it also comes as the Supra Plus pipe with an anti-frost protection cable. We've recently also launched a very smart solution. We've launched it about a couple of years ago, which is the ThermoTwin HP pipe, which stands for heat pumps. So this pipe combines 2 pipes for flow and return and 2 conduit sleeves for power cable and sensor distribution, all in one jacket. So you can understand that you only need actually 1 pipe to connect your heat pump to the building for hot or cold water applications, which actually reduces the installation times and the trench sizes. This pipe has been developed especially for heat pump applications. And moving forward, we recently launched the next generation of Ecoflex Thermo, the Ecoflex Thermal VIP, which stands for vacuum insulation panels. And when I say recently, actually, I mean like a month ago, so it is actually a brand new product. The VIP technology provides very low heat losses, great flexibility, and reduces the pipe diameter of the pipe. The higher performance of the pipework comes from the integration of the VIP insulation within the overall insulation layer of the pipework. The VIP insulation actually has a lambda value of 0.04, which is 10 times lower than PEX foam insulation and leads to lower heat losses from the pipework. Here you can see a very nice illustration of the heat losses of our pre-insulated pipe buried in the ground with and without the VIP insulation. So you can see the effect of VIP insulation layer towards reducing the amount of heat that is transferred from the water inside the pipe to the PEX foam insulation and then through the jacket to the ground. And then you can also see the reduction of the temperature spread within the ground after the heat goes out of the jacket. You can understand that overall it contributes to achieving approximately 60% lower heat losses for the same jacket sizes. So up to this point, we actually discussed district heating networks and how crucial delivering a highly efficient network with low heating losses is. Now let's see what happens when the water enters the building and gets distributed internally. So I'm sure that we've all read articles and studies around the carbon footprint of buildings, and probably one of the key points that we need to consider when discussing about lowering the environmental impact of a development is that the MEP systems actually contribute only a small amount of the overall carbon footprint of a building. So you can see these charts, which have been taken by CIPSI Journal, and they illustrate the refurbishment case study of a commercial building in the United States, and show the impact of MEP systems compared to the whole building for 3 different scenarios: high, medium, and low impact of the refurbishment. As you can see, the proportion of MEP carbon footprint is very small compared to the whole building environmental impact, unless there is some kind of leakage in refrigerants, which actually causes, obviously, the global warming potential to explode. Looking at the plumbing system, we can see that it only accounts for 2 to 3% of the overall footprint of the building. However, there is lots of skepticism regarding the sustainability of the plumbing distribution systems, and especially when the discussion comes to plastic pipework, with copper actually being perceived as a more sustainable solution because copper can be recycled, while plastic pipework cannot be recycled, at least fully in most occasions. A very useful tool to assess the environmental impact of materials and products is the use of environmental product declarations, or EPDs. So the EPDs actually assess the environmental impact of a product against 7 different criteria across the full life cycle, from manufacture to end of life. Some of the criteria that EPDs take into account is the global warming potential, the ozone depletion potential, and the depletion potential of abiotic fossil or non-fossil fuels. So in order to be able to assess the environmental impact of plastic pipework and how it compares to copper pipework, the European Plastic Pipes and Fitting Association worked with leading plastic pipe manufacturers, including Uponor, in order to create a full EPD comparison between copper and plastic. So in this chart, you can see the environmental impact differences across the 7 EPD criteria, we previously mentioned, between multi-layer composite pipe and copper pipe. So as you can see, MLC pipework clearly outperforms copper across all environmental performance categories. So this is due to the much lower emissions of greenhouse gases during the production of pipe and fittings. Also, the transportation of MLC pipework contributes less to the overall environmental impact compared to copper, mainly due to the lower weight of the pipes. And in total, as an average, MLCP has approximately 65% less impact when compared to copper. The same principle applies for PEX pipe as well. And you can see the comparison between PEX and copper in this chart. So similar to MLC, the same manufacturing and transportation reasons make PEX pipe to have 70% less impact in terms of environmental impact when compared to copper. So in terms of the plumbing products that we have available in our range in the UK, we have a full portfolio of pipes and fittings, which includes the seamless aluminium composite pipework, the multi-layer composite pipe, and PEX pipe, which you might also come across as quick and easy. The seamless aluminium composite pipe is available in sizes of 16 to 32 mil, and the multi-layer composite pipe comes in sizes from 40 to 110. For the smaller sizes of SACP, the fittings range include the Express Plus and the ring tension memory connections. For the larger pipe sizes of the multi-layer composite pipe, the fittings range include the Modular RS fittings and the Express range. So the SACP, or seamless aluminium composite pipe, that we've launched last year has been developed by Uponor and is the first multi-layer composite pipe in the world that comes with a seamless extruded aluminium layer within the pipe structure. This aluminium layer ensures great flexibility and up to 40% less bending radius compared to common MLC pipes. Also, the pipe doesn't require any readjustment during installation as it stays in shape after you bend it. The greater flexibility of the SAC pipe leads to an installation which can take place with up to 15% less fittings, which leads to reduced installation times and lower risks for leaks. The multi-layer composite pipe is available from Uponor for the last 30 years. It comes with a 5-layer technology with an aluminium layer in the middle of the pipe structure, and benefits of the advantages of both metal and plastic pipework. The aluminium core also prevents oxygen ingress, reduces expansion rates, and provides great stability for easy and safe installation. The MLC is highly resistant to pressure, temperature, corrosion, and calcification, and it can be connected to traditional copper systems. And it obviously comes with all the relevant approval certifications from RAS, DV, GW, and Kiwa, similar to the SAC pipe. The available fittings range for SAC contains the Express Plus and the ring tension memory ranges. So the RTM fittings are available for sizes of 16 to 25 mil. They are made of high-grade PPSU and provide 100% review capability, while the installation doesn't require any tooling or any high-end training. The Express Plus range is the latest fittings range that we've launched. The fittings are available in metal or PPSU, and they come in sizes of 16 to 32 mil. They are really easy to install, and the fittings come with a leak path in order to ensure that the joints have been correctly installed and provide 100% connection review capability as well. The key benefits of the Express Plus range is that the fittings are tough as they are highly resistant to mechanical stress. The connections are safe because of the unique press indicators which assist in precise jaw fixation and accurate test safety function. The fittings are very easy to install and provide improved flow characteristics with reduced pressure drops by 60%. The innovative QR code enables fitters to quickly access all the product information through their mobile device, and the different color coding recognition for the different sizes is a really smart way to avoid any installation issues on site. For the larger sizes, between 63 to 110 mil, we can offer our modular riser system, which uses just 40 different parts and enables installers to create over 300 fitting combinations. The modular riser system is intended for large scale, for large pipe diameters, but the fittings range also include adapters for as small as 16 mil pipe. It is a system that is really easy to install. It reduces installation times and any associated costs. And the system also comes with color coding recognition in order to avoid any issues on site during installation. The third pipe range that we have in our offering is the PEX pipe, which is also known in the market as Q&E, quick and easy. The PEX pipe contains a high degree of cross-linking that gives the pipe a special memory effect. So this technology actually improves the elasticity of the pipe and ensures great compatibility with the quick and easy shrink fit connections. The PEX pipes are also highly resistant to pressure, temperature, corrosion, and calcification, and ensure low thermal and friction losses. The connections for the PEX pipes can be made in a very quick and easy way, hence they have that name. So you can see the installation process on the right side of the slide. The fitter actually needs to insert the ring to the pipe, then expand the pipe using the Uponor tool. And when the pipe work is expanding, the fitting can actually be inserted in the pipe. The pipe will then shrink back to its normal position and will create a safe connection with the fitting, taking advantage of the cross-linking technology of the pipe. Another benefit of our PEX pipe is that it can be used for recirculation systems, and same as SACP and MLCP, the PEX pipes are ideal for hot and cold water systems for both commercial and domestic applications. All right, so up to this point, we've discussed how district heating network can be optimized in order to increase their efficiency and reduce heat losses and CO2 emissions. We've also covered how we can reduce the carbon footprint of a building by switching from copper to plastic pipework. So let's now see how do different heating and cooling systems compare to each other in terms of efficiency. These are two charts that I've taken out of a very nice case study that my Uponor colleagues in Denmark have prepared in the recent past. They saw the annual energy consumption and the annual CO2 emissions for a typical house in Denmark, and the charts came out of a simulation. Obviously, the heat requirements of the building stayed the same across the different scenario simulation. So as you can see, underfloor heating was compared to radiator and fan coil heating systems in conjunction with different heating sources such as district heating, oil boiler, gas boilers, air source heat pump, and ground source heat pump. As you can see, for all the different options, underfloor heating had the lowest energy consumption and CO2 emissions among all the different options. You can also see that by feeding the underfloor system at water temperature as low as 43 or 33 degrees, the system is able to provide the required loads, and especially when combined with a renewable energy source, such as a heat pump, the results can be extremely beneficial for our pocket and the environment. This slide, we can see the results, which actually came out of a university research that has been published by Marquez et al. The heating system combined of a heat pump and 4 different scenarios have been simulated: radiant floor, fan coil with optimized control strategy, and radiant floor with a preheat period. So the combined scenario of using both the floor and the fan coil for heating was also examined. As you can see, and especially in the results for London, the radiant solution has the lowest energy consumption compared to the rest of the systems for all 3 different part load curves of the air source heat pump. Also, as it comes out of the same research paper, the underfloor heating system provides better thermal comfort levels in all different scenarios. The main reason that radiant systems are highly energy efficient is that they have the benefit that heat transfer takes place via a large emission surface, which actually makes these systems able to operate at lower water temperatures for heating and higher water temperatures for cooling. This results in reducing the energy consumption of the heating or cooling source, which actually leads to both decreased costs and reduced CO2 emissions. In addition, low water temperatures make radiant systems ideal for integration with renewable energy sources, such as an air source heat pump, a ground source heat pump, solar thermal systems, or CHP. I think my laptop just crashed for a bit. So in the next slide, we're going to see actually the systems that are available for all sorts of applications, all sorts of different applications. Systems such as underfloor heating and cooling systems for domestic and residential projects, for commercial and industrial projects as well. Including actually some systems that may be unknown to the wider audience that we're going to showcase in a while, such as the thermally active building system. Within the Uponor range, we have solutions for all sorts of applications, and we can also offer smart controls for higher energy efficiency. So we will start with the most widely known application of a radiant solution, which is the underfloor heating systems, and more specifically the systems that are mainly applicable in domestic and residential applications. So Uponor's Minitec system is actually a prime example of a low-profile underfloor heating system. It is ideal for renovation projects as it has a minimum buildup of 15 millimeters, including the 10 mil pipe. The system comprises of the Minitec panel, which is castellated panel with a sticky lower surface. The adhesive on the lower surface is used in order to attach the panel on top of an existing solid floor, rigid insulation, or a timber floor overboard. The pipes can be laid inside the upper side of the panel, which is actually routed. On top of the panel and the pipes, something like a leveling compound or something similar needs to be poured with a minimum thickness of 15 mil and a maximum recommended thickness of 30 mil in order for the system to maintain its high efficiency and performance. The benefits of the system is that it is a very high response system with high performance for both heating and cooling. Some other systems that are commonly used in domestic applications are the ones that comply with timber floor constructions. A system that actually you can find in our range is the Zisis FX panel, which is a 30 mil EPS routed board with aluminium foil on the upper side of the installation panel. The system actually provides very quick installation times, as there are only two parts of the system that need to be installed, the panel and the pipe. Compared to a heat emission plate system that you need to install the insulation board, then you need to install the heat emission plates and then the pipe board. But of course, we also offer heat emission plate systems for all different types of joisted and floating floors. Moving forward to more commercially used systems, which are used in residential applications too, however, we have the traditional in-screed system. So the in-screed applications are the most common type of underfloor heating systems that are being used. There are many different ways that the pipes can be installed in the screed, and Uponor can offer all these types of systems. The most commonly used is the tacker system, where pipes are actually clipped on top of rigid insulation. It's a very easy to install system and very cost efficient. And we can also offer the Nubus system, which is a castellated panel with a sticky lower surface, something like a big Minitec. And it's an ideal solution when there is no insulation below the screeded floor. Both these systems are easy to install and have high performance for both heating and cooling. Another very good application of underfloor heating and cooling system is the industrial and sports school projects. The main benefit for these type of systems is that primarily they're installed in areas that have high ceilings. Therefore, the underfloor heating is ideal as it creates a thermally comfortable environment in an occupied area of 3 meters high without having to warm the whole air void above this level. Especially when it comes to industrial applications for warehouses and manufacturing facilities, this is very important for the well-being of the occupants, as the radiant solution actually reduces the dust circulation, and the system ensures that it comes with a low investment and low operational costs. Another system that can be used in order to provide cooling and heating in a building is the thermally active building system. In this case, pipes are embedded inside the structural concrete slab of the building, primarily in ceilings or walls. It is very important actually to understand that tubs is not replacing a ventilation system, but it actually uses the thermal mass of the concrete structure in order to exchange heating or cooling with the adjacent areas. In terms of how the system works, the embedded pipes actually activate the concrete slab of the building. The system actually uses the building mass in order to store energy and then exchange this energy with the adjacent areas. In terms of the benefits of implementing a thermally active building system is the high thermal comfort, as most of the radiant heating and cooling systems, low maintenance cost, and low investment costs. Here are two examples of a simulation of commercial offices building, actually comparing the primary energy usage of tubs compared to conventional HVAC. As you can see, the tubs have the lowest energy consumption among the different compared systems, especially when combined with a ground source heat pump. And obviously, the lower energy consumption is translated in lower annual energy costs too. But in order to go the extra mile, we actually simulated the building and compared the cost for the whole life cycle, of the development for all the different systems. So again, tubs have the lowest whole life cycle cost when compared to all the other systems. Other solutions for radiant heating and cooling that you can come across in our range are Renovist panels and the fixed 9.9 systems, both applicable for wall and ceiling application, and it's a very good alternative when an underfloor heating system cannot be installed, or when the system needs to operate for cooling as a primary operation mode. In terms of controls, there are many different technologies that have been developed over the last years in order to work in to assist controls in order to be more cost efficient and provide better thermal comfort and less energy consumption. One of these technologies is the Autobalancing technology, which is a continuously self-optimizing temperature. And in fact, the Autobalancing technology can provide up to 20% energy savings compared to unbalanced multi-zone systems. In our UK portfolio, we have a wide range of controls options for both domestic and commercial applications. Our commercial options provide BMS integration as well with our Smatrix-based Pro range. And the newest system in our range is the Smatrix Pulse, which is a cloud-based system that controls both underfloor heating and cooling systems with smart control operations. Whenever you are, even if you are outside your house or your apartment, you can control your temperature and humidity levels through your mobile app, and you can also connect the system to Amazon Alexa and Google Assistant. So as a conclusion, there are available solutions in order to make district heating networks more efficient by using pipework with higher heat loss performance. We can make plumbing systems more environmental friendly by using products with lower carbon footprint, and we can use alternative radiant heating and cooling solutions which operate at lower water temperatures compared to conventional HVAC systems, which actually leads to less energy consumption and also if we incorporate smart controls, we can improve the efficiency of these systems even more. Uponor has a full portfolio of products in order to provide highly efficient turnkey solutions from the energy center to the final emitter and assist the industry to deliver more sustainable buildings in order to reach the overall target of net zero buildings. I'm a bit conscious of time, but I would like to run through especially this exact project. So the Jaguar Land Rover project, it is a project that we've recently completed and actually was a very innovative and sustainable development designed by Bennett's associate architects. So we've worked with Lenk O'Rourke, Crown House Technologies and Bureau Happold in order to design and supply a turnkey solution by transferring water to the building with our pre-insulated underground pipework, and then heat and cool the building with underfloor heating in slab, tubs, and also radiant panels across different areas. There are many more project references that we have, and we can spend hours discussing about it. But now I will yield the floor back to Ben, so in order to run through any kind of questions.
Yeah, that's great. Thanks, Zisis. That's really informative and a huge amount of information there. That's really brilliant. Some wonderful products that you're running through. I know James Griffiths from Uponor as well is also here in the background to sort of start answering any questions that you have. So do pop those into the Q&A box as we go now. One which I think James has already typed a response to, but maybe James, you might like to expand on that just for anyone perhaps who's on the move or hasn't seen that, is a question. We've got an anonymous attendee who's asked, how does the UK's approach to heat networks sort of compare to the rest of the world? I don't know, James or Zisis, would you like to expand on that answer at all?
Yeah, I mean, obviously it's no secret that heat networks have been or had various success throughout the UK, and some have been questioned as to their suitability. I mean, if I'm being open, in comparison to Central Europe and the Nordic regions, we haven't quite got it right yet, but there are certainly been large developments within CIBSE and the Heat Networks Code of Practice for the UK, the CP1 document that was launched this time last month. That's a real step forward looking at different technologies. It's no longer burying the biggest pipe you can find and hope that it gives the heat output. But yeah, we're certainly a long way from some of the technologies that have been used successfully in the Nordics, and we do need to focus on diversifying and looking at how we use energy and basically providing the biggest pipe to assume that everybody at 8 o'clock in the morning, for example, is going to turn the hot water tap on the shower and every appliance in the building is just not the correct approach. So we need to get smarter.
Mm-hmm. Yeah. Okay. And let's another couple of questions moving on. What are the main challenges for air quality in high-rise buildings? And is there sort of you perhaps touched on that before? Do you want to just give a quick, I don't know, summary, if you like, of that?
Yeah, I suppose again, air quality, it really looks on like what you want to achieve. I mean, if you're looking at high rise, the certain history for the last 5 years has been creating these wonderful feature towers with lots of glazing. There's a number of issues with regards to, well, what it means to be able to provide a good central air. Dare I mention it is showing some major failings with central air. But I think from my point of view, it's looking at what it is you're trying to achieve for the occupant. For me, it's not about providing a system that is better or above any of the rest, but looking at the end user and understanding the well-being of that end user. Often we take for granted that if you're inputting cooling into an area, it is primarily because there is an overheat scenario. And for me to see HVAC as being designed to provide cooling I probably look that there's probably a number of other elements that we could have done within that building design to eliminate the need for cooling and obviously maintaining air quality. But again, that's just one little factor. If you look at thermal comfort, you've obviously got to take into account noise, air quality itself, about actually whether or not it's creating 6 building syndromes and so forth, and ultimately CO2.
And also taking point from what James said, and from one of the other questions on what is the best example of a healthy, sustainable tall building in the UK, I think it is fair to say that we've been involved in the Advanced 2 project for Dudley College a couple of years ago, where we designed and supplied a thermally active building solution that actually works 24/7, 365 at 26 degrees water temperature, providing high thermal comfort levels to all occupants, and also reducing the energy consumption of the whole building to the minimum. On the back of that, we've recently been involved on the second phase of this project, again with Dudley College, and the building actually, the new building is going to be 25% more energy efficient compared to the phase 1 building. And it is worth mentioning that both buildings do not have a mechanical ventilation system implemented. They both work with natural ventilation systems only.
Yeah, passive facades.
Okay. So how about Kirsty's raised the question here about, do you currently work with any local authority or housing association projects? And how successful have you found that, especially in terms of retrofit? There is a whole another episode you can look up on our YouTube channel where we've talked specifically about sort of social housing, Kirsty. So do point you in that direction. But Zisis or James, would you like to take that one?
Yeah, so we work with a number of local authorities, but again, there's a number of requirements that local authorities are looking to achieve. There are a number that they're wanting to achieve and within what time scale. But retrofit, the development of the Minitech was for us crucial to local authority development. To be able to put a radiant heating and cooling system, which would primarily have been radiators served with copper pipes. There's a number. There's no argument that overall, if you look towards Minitech as a surface heating system versus radiators, the efficiencies that can be achieved there. Also, when looking at local authority schemes, they obviously don't always come with what I would call the project credentials to go immediately to net zero and the high sustainability in affluent areas. So again, removing some of the risks and considerations that people have to meet within a building control environment or an area that's less affluent by development. Again, it really, really depends on what it is that the authorities are trying to achieve at what point. Okay. Sort of leads me, I suppose, then into the next one. Is net zero achievable?
Yeah, you just broke up there, James. I'll repeat the question. Sorry, you were just breaking up there for me. But yeah, and maybe it's the last question that we end up taking. I'll get you both thoughts on it because it brings us back to sort of where we started. But in your honest opinions, yeah, is net zero achievable given timelines and budgets and things that we face at the moment? So James, yeah, do you want to take that?
I'd like to think so, and I'd like to say yes. But we've all got a way to travel on that journey, and it is everybody. There'll be trials and tribulations and things that won't work, but I think if we're going to really make a step forward for this, we need to be honest and either say we're in from day one or that we're not. And I'm a strong believer that every system has a place, and it's not fair to eliminate certain criteria, I believe, within what might come about with achieving net zero to say that it has to be X, Y, and Z from day one. I think if we're all open to achieving goals and learning from those goals, then yes, we can achieve it. Timeline and budgets, I think that's a little bit of a crystal ball at this time. But again, I think tomorrow we'll have a little bit more insight into that.
Yeah, exactly. Actually, there are lots of things that need to be done for the industry to start hoping that net zero will be achievable in the near future, in the next coming years. But as James mentioned as well, we have the roundtable discussion tomorrow, again with Elemental, that we are going to discuss exactly this topic. So it would be worth joining that session too, in order to understand the different aspects of what needs to be done and get the insights from different people within the industry.
Absolutely. Perfect segue. Thanks for doing my job slightly there for me. 1 p.m. tomorrow. If you haven't registered for that session, do go on the website and on the Eventbrite page, you'll be able to sign up to listen to that completely for free. We've got a fantastic lineup. Obviously, James and Zisis also will be joining as part of that. So that's at 1 p.m. Again tomorrow. I just want to say thank you to both of you. Thank you to Uponor who are sponsoring this session, and it's been a fascinating presentation. And if you want to watch it again, we've been recording it, so we will have that up online and on YouTube very shortly. So we'll be sharing out that information, and then also I think the white paper report is available to download, isn't it, Zisis, from the website?
Yeah.
So obviously worth kind of digging into that. And if you have any further questions, don't hesitate to get in touch. I'm sure that the guys will be very happy to answer them and take them afterwards. So without further ado, I guess I will just close this session for now. So look forward to hopefully seeing everyone again tomorrow, certainly seeing Zisis and seeing James again tomorrow. Thanks, guys. Have a good rest of your afternoon.
Thank you very much, Ben, and thank you to all the attendees. Looking forward for tomorrow's discussion. Thank you.
Perfect. Thanks very much, everyone.
Thanks.